Lab 9, Introduction to 3D Printing. Hi, Joe Cerrone. Today we're going to model and print this napkin holder. We can find the dimensions right here. And so this is taken from our 3D Printing Projects textbook. And he's using SketchUp and then exporting the STL file. 3D printing time 90 minutes at a 0.4 millimeter layer height using an UP 3D printer. We're going to print these on our Bosch Dremel and Ultimaker printers. The drawing is made in millimeters, and so we have this drawing that's 157 by 94 millimeters if we take the length and the height, and then the thickness and the radii are given here for these different features. We have the base, that's the base right down here that holds this triangular shape to the base. And essentially they go through the modeling aspects for it. We've already worked with some of that, and so what I've done is I've given a student file. And we're going to work with the newer version, which is going to use inserts. And so I'm going to download this file and open it. And so this is an AutoCAD file. And essentially, if we look at this in an isometric view with conceptual visual style, we can see that we have this oak leaf. And what we're going to do is we're going to print the oak leaf using horizontal expansion, so it's slightly smaller and fits in here, kind of like a jigsaw puzzle. And then if we look at how we modeled this exercise, we can go to a top view. And if we look at our print, we have this triangular shape that's 157 millimeters by 94 millimeters. And so if you've opened up the student file like we have, we can analyze this, and we can see that that's 157 millimeters. And then for the height, we can just track a line. From this intersection here, and if I click on that, we can see that that's 94 millimeters. And that's the dimensions that we want. So as we're designing for 3D printing, we want accurate dimensions. But as we're making certain products, this is sort of a consumer product. We have some flexibility, creativity. So what I've done is I've drawn that shape, or provided that shape, and then showing how that is modeled, trimmed it, gotten the basic shapes. And so these are the geometries, and notice that they're closed polylines. And then what we've done here is to extrude these parts. And so if we take an isometric view, here's the 2D geometry. And then what we did was we either press pulled or extruded it. If I measure the distance, I can see that that's 3 millimeters. And so to do that, what we would do would be using a 3D workspace. We can either use extrude or press pull. Press pull is a little easier, We make that 3 millimeters. And then we can verify that with conceptual. All right, and so that's how this geometry was created. And this is the base, and it's the same. If we go through and we look at the dimensions for the base, we'll find it. We've got this 60 millimeters by 60 millimeter rectangle. And then we're going to take that rectangle, and just like we did with the other side, we're going to extrude that 3 millimeters. And then we're going to assemble it. And so after we've extruded these 3 parts using either press, pull, or extrude, we can use 3D rotate. And we can select that geometry, hit enter, put the gizmo down here in the corner, and then we can select this red axis as our axis of center for the axis of revolution. And notice that I'm using polar tracking, and that's what this button is here. Polar tracking will keep things straight, but if you have difficulty with polar tracking, you could use ortho mode as well. And so we're going to rotate this one as well. And before I rotate the other one, I'm going to put it together. And so what I'm going to do is I'm going to move it, and we can just use regular move commands from this end point. This end point. And then the same thing with the other side. We can 3D rotate that. Place the gizmo at the corner here. Select the axis of revolution. Track that north, and then track that this way. Move it. And then once we have created that, we're going to union that together. And so unioning it will be like glue, because we could still move these components. They're not glued together. And so once we place them in the proper configuration, what we'll do is we'll union those, and then we'll combine them. And then you can see we've extruded this bottom shape as well. And then I placed that bottom shape on the bottom here. That's a little bit tricky. The way that I would do that would be to move that in wireframe and place an X on the bottom of the geometry. And so if I were to repeat that, actually what we want to do is to be able to move this from this intersection to this intersection. And so if we were to select the move command, you can select move, hit enter, and then move it from this intersection to this intersection. Verify it, conceptual, and then we would union that together as well. And so once we have those shapes, we would union those. And so same process. I can see that these other ones have been unioned. This one is not. And so what we would do is we would union that, select these 2 shapes, hit enter, and now they're treated as one solid geometry. All right, so to create and put the oak leaf onto the napkin holder, what we want to do is to extrude this, and we want to extrude that. If I check this piece here, let's see. We're going to extrude it 2 millimeters, and then we're going to subtract it. And so we're going to line this up with a line from the center here, and I'm just going to track this down in the Z direction to this midpoint. And then I'm going to extrude this 2 millimeters. And then what I'm going to do is I'm going to 3D rotate it and move it. I'm going to put the gizmo right at the center here. I'm going to select this as my axis. And then I'm going to move it again over to this area here. And I'm just going to place it on this with a nearest O snap. We want it to be attached. Now that I have placed that onto the face of this other part, what I want to do is to press it in just a little bit and then subtract it. And so we're going to use a 3D move command here, and then we're going to subtract it. And so one trick that I like to do is I'll create a copy of this line, but actually I think I have a second set of geometry there that's going to be fine. So we'll subtract this, but before we subtract it, we need to press it in just a little bit and then subtract the geometry, because right now we just have the two surfaces against each other, and we can see that in a 2D wireframe. And so if we look at that, this does not intersect with this green geometry here. And so we're going to make that so that it does by using a 3D move command. So we'll say 3D move, and then we'll select the geometry for the oak leaf. Hit enter, and then grab this axis right here and push it in 2 millimeters. If we look at that, holding shift in the middle mouse wheel, we can now see that it goes in. Let's check and see if we didn't bring it too far. And so it goes up to the face, which is fine. We're going to go back to 2D wireframe, and then we're going to subtract that. And so we're going to say subtract. We'll choose the large shape first. Hit enter, and then the geometry to subtract from it. If we hit enter, and then if we shade it, we can see that that geometry now creates kind of like a jigsaw puzzle shape for it. And then we can do the same thing for these other two components right here. And so we'll subtract those, choose the larger shape, hit enter, and then these leaf geometries. All right, we can map it to the back side of it just the same way. Okay, so we can bring this over here to this side and subtract it. But in the sake of making the video, I'm going to go on to the next component. And so now that we have created the geometry for this, what we're going to do is we're going to bring that into our slicer, and we're going to bring in the STL file for that. So what we'll do is we'll export this. And I usually just put these in my downloads. And so we'll select that geometry and hit enter. And then we'll also extract the oak leaf. And so I have another geometry right here. And I'm going to extrude this 3 millimeters. And so I'll have an extra millimeter of overhang. And so we'll say extrude. We'll select this, hit enter, and then we'll move that up. We'll type in 3, enter. And then we'll export that. We'll select all of the geometry and hit enter. All right, now that we have exported the base for the napkin holder and then the logo, we're going to go into our slicing software. And so we're going to go into our Dremel slicer because it's a single nozzle extruder. And if we want to work with 2 colors, then we'll make like a jigsaw puzzle type of an effect, where we'll use two different machines or 2 different filaments with different colors. Alright, so here we are in our slicing software, the Dremel 3D 45, and we can see here's our platform, our build plate. We're going to be using PLA, polylactic acid, and we're going to go and open up our file. And so we'll say File Open, and I'm going to bring this in from the downloads, and I'm going to bring in the napkin holder geometry. And the orientation came in just fine. If we look at this, I don't think we're going to need any we're going to need to generate any support. We're going to set this up at low quality or 0.3 millimeters. For build plate adhesion, we've got a skirt which will just prime the nozzle. We can bring this down to a brim, and I'll show you both of them. Let's go with the skirt first, and we'll prepare it. And then if we look at this, the eyeball here and the layers, we can see that basically what the skirt does is it just primes the nozzle on the first layer. And so if we bring this all the way down to layer number 1, that basically is the first thing that's going to be printed. It doesn't really hold the product to the build plate, and so if we wanted to change it, we can change it to brim, and then since we've made a change to the model, we need to re-prepare it. And that will hold the build plate to the part much better. And so as we look at the model, this will keep it from peeling off of the build plate and giving us some problems. So this looks great. We would go ahead and save this to a removable drive and print it. You can change the name here. And I'll save that to my removable drive. The next thing that I'm going to do is I'm going to delete this. And then I'm going to bring in the oak leaf. And I'm going to leave all the settings the same. And we didn't make any changes to the geometry to make up for trying to have a tolerance, or the oak leaf needs to be slightly smaller so that the pieces will fit together. And there is a factor in our slicer that'll allow us to do that, and it's called horizontal expansion. And so what we're going to do is we're going to adjust that. And so here's our horizontal expansion variable. And what I'm going to do is I'm going to set the gap to minus 0.2. And then I'm going to prepare this. Now for this part, I'm not going to use any of the build plate adhesion because it's going to take a long time to post-process it. And it's a very short time. It's only 13 minutes. And so we'll remove that. So we want to set our horizontal expansion to -0.2. And then what we want to do is we want to change our build plate adhesion. And we'll just use a skirt. And that will then just prime the build plate. Alright, and so what we'll do is we'll print this one in one color, and then we'll print the other one in another color. And then we'll take a look at those on our 3D printer. If we look at our layers, we basically got 10 layers, and we're going to save this as our oak leaf, and then we'll make another video to show how the print worked. Alright, that completes this video.